Okay, so now I'm going to use my non-golden screwdriver to open this beastie up. We're going to have a peek. I don't expect to see anything in here other than a regular, plain Jane, modern surface mount radio. That's all I expect. So let's have a peek. Yep, that's what I thought. Do they make any other kind anymore? Unless it's a company that sticks to predominantly through hole, you know, Ranger and Friends. So yeah, let's. Of course, looks like that whole bloody connector is actually trying to come out. When I try to unplug the speaker, the whole socket and everything is trying to come out. Yeah, I mean, what else is new there? See if I can't just get that to stay. Nope, the whole thing's gonna come out. Cheap connectors, built to a price. Not surprised at that either. So let's have a look-see and see what we see. All right, so we got shielded areas. So we've got some shielded areas, probably PLL VCO. PLL chip is right here. It looks like a BU2630, which it is. It's a BU2630. Interestingly enough, they're using both PLLs. It's a dual PLL, and they're actually using both. I see tracks from both sides of the chip, and it's pretty much split. One side's one PLL, one side's the other PLL. So I've worked a lot with them, so I know they're using both. All right, so they're using both PLLs, and that would actually make sense now to think about it. This radio did 100 hertz steps, so in order to do 100 hertz steps, you use both PLLs and you sum them together and you do your offsets. So there's a lot more to it, but that's essentially what you're doing. We got a microcontroller, doesn't have a manufacturer's logo or anything on it, just numbers, and I don't recognize it, so it's probably masked or custom chip, or it's just a knockoff. One of the questions I did get was about these coils. Now this is a stock radio, it's just factory, you know, come to me, and it's never been fiddled with. About these coils and the reason that they're spread from the factory. Or one question was, if look at my screen over here, is are they supposed to be spread? And if they're supposed to be spread, why are they supposed to be spread? And of course, the other one was just why are they, you know, why do they do that? Well, they don't have any variable inductors in here, so the only way that they're going to be able to tune it is by spreading them a little bit. That's just it's pretty much just the way it is. So in a radio with variable inductors, you don't want to see split inductors like this unless it's intentional. But generally, as a rule, you don't want to see it. But on the radio like this, there's no variable. What else are you going to do? You got to spread them a little bit. It's just the way it is. And of course, the other question was about these cans, these shielded areas. Well, you don't want PLL noise getting into the receiver and receiver noise getting into the PLL, so on and so forth, or transmit RF deck stuff getting into the PLL. You don't want that, so they shielded it all, and that's perfectly fine. So that was a attention to detail that they paid, and that's good. Overall, I mean, just at first glance, I don't really see any, you know, glaringly bad things about the hardware. I don't think that these have hardware problems. I think the software is dodgy. The user interface is just shit, and you know, that's going to be the next thing I'm going to look at is the data bus, just because, well, I'm curious. So we got a cable coming back from the USB, and that's probably what this is. It's coming over here to this connector, and so this is the first thing that's interesting, and I can't really tell if they've got a proper protection, input protection on this USB. I don't see that at all, actually. I think it just goes from the connector straight into this cable, and then this cable goes straight over here, and then we've got some inductors and we've got some resistors, but this does not look like a USB interface at all. I don't know what this is, but this isn't USB. So, what are they doing here? Interestingly enough, actually, I think it's labeled RxD ground and TXD, so that's not USB. That's something else. RS-232, but they've got a USB. What in the world? They mislabel it? I mean, that would be D plus D minus if it was USB. That they just bollocks up the silkscreen, and I don't know. I don't trust it. So, because it's mislabeled, I'm not plugging that thing into USB. I'm not going to put my cable into it. Let's take a look at it with scope and see if this has any semblance to USB. Oh, it's not on. That might help to turn it on. No, I'm not plugging that into USB because that's not USB. No, that's not USB at all. I'm curious to see if it's transmitting anything. If I change anything. No, that's not USB though. No, that's not USB. That's something else. I have to come back to that because that just looks interesting, because that's definitely not USB. I mean, if that's USB, that's a absolute shit interface for USB. It just no, it's not USB. Anyway, so as far as this front panel and the user interface, these connectors, they all have their own harnesses that come down to the board. That clarifier that has the encoder on it, that's coming down clearly on this cable, because I could see where it's just split, and this cable is dedicated to this control, and so on and so forth. And that's just coming straight down here, and I would be willing to bet that that's just being controlled. This micro is taking this encoder data and processing it. So that encoder is processed by this microcontroller. These are just obviously analog-y bits and bobs, you know, volume control and squelch and so on and so forth. So that's you know, nothing interesting. This other control over here that has the power and the talkback and all that, it's got its own harness as well. So none of those are connected to the front panel at all. This cable here is going up to the microphone connector. We got audio and probably, you know, the ground and the transmit line. I'm betting that's all that is. There's probably silkscreen on there anyway. A PTT key ground mic. So a key could be a key scan line. So that might probably be what that is. I have not looked at the microphone for this to see if there's any buttons on it or anything. It's probably just key scan line. And last but not least, we got this other cable down here, and this is the only one that's actually going to the front panel proper. Now on the front panel, we have a chip on board that's going to be an LCD driver for this LCD here, for this meters, and the character display. And it's just chip on board. It's typical, you know, low-cost construction. These other two QFPs that are down here, it's one of them is a Megawin. That's a microcontroller. I can't read the whole number because they got like a crayon or something on it. And the other one is a Holtec. That Holtec's going to be a LCD driver. It's probably going to be for this. Not LCD. It's LCD. You know, typical LCD driver. Not because this LCD is. When it powers on, you could see that it's, you know, a custom glass. It doesn't have its own driver, and that's what that Holtec chip does. Because when the radio initializes, I can see the display sort of like a test mode. Before it lights the backlights up, all of the digits are running. So it's just a display driver. So anyways, we got this one cable. We got one of them that's shielded, so it's probably a data bus to play with. We got 3 wires and 3 wires. One's the ground for the shield, to shield that other one there. We had a white and red, so see what the silk screen on that says. That's RxD ground, TXD ground, 8 volts, 13 volts, which is, that's very interesting. Are they running... USB is questionable because they got that labeled RxD and TXD as well, which implies RS-232. And this one is also labeled the same way, and that also implies RS-232. And I couldn't think that they would be able to get, unless they were running it, you know, 115K board or higher, to get a decent refresh rate of the display. Because that's one of the things I noticed about that display is refresh rate's pretty low. So yeah, let's probe the RxD and TXD going up to the display and see if it's maybe just I2C and they mislabeled it. Like in the Cobra 29 LXs, they actually call it RxD and TXD. It's actually I2 as a SPI bus. So let's see what we got. We got the same conditions as we have on the other one. It's just pulled high. No activity. So let's change something. Oh yeah, there's something there. Okay. A single shot capture, and we got one character. RS-232. That's definitely RS-232. And that would be, that's RxD. So if that's labeled RxD, I'm guessing the other end's going to be labeled RxD as well, unless it's labeled TXD, which would make sense because if it's RS-232, I can see it on the scope. It is what it is. And it's pretty slow too, and that actually explains the refresh rate. They're running this at pretty low rate of speed. So this is RxD. That means the other end's TXD because you transmit into a receiver, and vice versa. So this one's going to be, this one would be data from the front panel to the micro down here, and it's just a single character. So I don't know what the character is because my protocol decoder on the scope is not decoding it. It doesn't understand this. It's probably a rate of speed that it can't figure out. Yeah, it can't figure it out. So it's probably an odd speed. The scope's generally pretty good at figuring it out, but it can't figure this one out. So, oh well. Yeah, it's just it is what it is. So let's see, just decode one. So let's just no, it can't work it out. I have to use a logic probe. I can muck around with it baud rate. So what about this? That's only transmitting one character when I change the channel. Seems like it's only transmitting one character. That's a different character, so we just single shot capture. We got one character. It looks like one character. So it's probably just very simple. No, that's two characters. We're gonna have to go to the logic probe, and what I'll do is I will stop this and attach a logic probe and continue this from a computer where you know, we can make some sense of it, because you know, the software decoders and the scope, you know, sometimes they work okay, sometimes they don't. But for something like this is probably custom baud rate. It's not gonna do it. This one presumably is going to be the micro to the front panel. So let's take a look at that and see. Ooh, big packets, very big packets. Okay. So that's the front panel controls are issuing one character, two character commands to the to this micro. And this micro is sending back multiple bytes of data to the front panel. So I will continue this from a computer. I'll just have to capture the screen. I'll hook up a logic probe to this, and we will fool around with the bus. Let's take a look at that data bus. I poked around with it a little bit just to make sure that I had the baud rate all set up and everything. It's transmitting at 19.2 K baud, standard serial baud rate. I have denoted the RX and the TX lines. So TXD here is the front panel to the main board, and RXD is the main board to the front panel. So when you see packets on the bottom, that's the stuff being sent to the display. And when you see packets up here, that's stuff being sent from the display. So if we go ahead and capture a simple channel up change. So I'm going to run the capture. I'm going to change the channel up 1, rotating to the right 1 time, and it transmits a single character command, which is a D, for when we are rotating to the right to go up, it transmits a D, and then it refreshes the entire display. So all of these bytes are for the front panel, and there's, as you can see, quite a bit of them. That's one reason why the user interface is somewhat slow to respond, is because they're sending so much stuff. Instead of just updating the portions of the display that they need to update, they just send the entire display, which is, you know, the foolproof way of doing it. But if you're going to send this much data, you certainly should send it faster than you're sending it. So, and that's why it has a somewhat sluggish response. And it's RS-232, and there's a significant delay from the time that the command is issued to the time that the command is responded to. It's not the fastest thing in the world. They certainly could have bumped the speed on this quite substantially, and it would have just been better. But they didn't, and that's all there is to it. So as you can see, they send some ASCII data to the display. I've got this set up for ASCII. Normally, you would look at this in not octal, in decimal, in hex rather. But because I'm making a video, I'm looking at it in ASCII. So that's the character part of it, where it sends the SR-955HP. Our single character command to go up 1 channel is a D. So let's see what it is to go down a channel. So I'm going to rotate it to the left 1 click, and there you go. And as you can see, it's a U. So my problem with this is, if a D is up and a U is down, what in the world were they thinking about here? That makes no friggin' sense to me at all. Why wouldn't you have down for down, a D for down, U for up, instead of U for down and D for up? Oh, come on. They just put this together hastily, didn't care about what they were doing, and they invented this protocol, and wow. I mean, so you have single character commands from the front panel to the main microcontroller over an RS-232 bus. Okay, fine. I'm on board. It's small, it's fast, it's one character, one byte of data, just poof, done. But then you send back all of this shit on a low-speed bus to a user interface that now has to draw all of that shit and respond to potentially somebody turning the control, which is why these encoders on this radio respond like shit. It's because it's being interrupted, because of course they're going to be doing RS-232 comms, which is, depending on how they wrote it, it's really going to be a blocking operation. So And that's what it appears to be. So it's got to wait to get this big, long string of shit that's being transmitted to it before it can send the next command. Oh. Where in the world, where are these guys' brains? I mean, it's a user interface, 19K baud. One character commands being transmitted, sometimes two. There is sometimes two characters, depending on what's being sent. And then all of this stuff, which is a blocking operation, because that's how they wrote it. Oh. Anyway, that's a fail. But it actually opens up some interesting possibilities, because that means computer control. You can write a computer program and disconnect the front panel of the radio and do your own interface. Low speed interface, but you can do it. So, you know, I don't know what all these bytes signify. That's going to have to be mapped out. But, you know, we've got 3 meters. We've got the ASCII display. We already know what the bits for the ASCII display are. Have to find out if these first bits are commands of some sort. You know, like, does this quote 4 mean, okay, we want to send we're sending ASCII data? Are these just bytes for padding, you know, kind of thing? And is this maybe the meter data or something like that? Don't know. It's all going to have to be worked out, you know, what each byte is for. So that's that bus. Now I've got to look at that other bus that goes from the back of the radio to the front. That's on that Type A USB connector that isn't USB. I have a sneaky suspicion that that's RS-232 as well. So, yeah. This isn't really very interesting. Yeah, sure, I'll probably sit here and map out every function. You know, when you send this command, it does this particular thing, because that's all it really is. You know, we want to go up or down, send a U. You want to go down, send or up, send a D. That's so crazy. So anyway, let's look at a few more interesting commands. So look at a two character command or 2 byte command. So we'll capture it, and I'm going to hit the func key. And so here's the first one. It's a T. T means something clearly. And then we send a P. Notice the lag time between you know, transmitting of that first command and then transmitting of that second command, which is the P, and then getting the response, which is the func, and all of the necessary display data. It's really slow. It is really slow. This is an eternity in time for microcontrollers. You know, this is just an eternity. So we'll try another one here. Let's try scan. And of course, it's another 2-character command. As you can see, this one's an R, and then a P, and then of course we have SR-955HP. I thought I hit scan. Let me try that again, because I thought that it flashed scan up on the display. Scan. No, it didn't change the display. So there's our R, and then the P came afterwards? That's interesting. Let's try this again. We're going to capture this, so we're capturing data. Yeah, I'm going to hit scan. Oh, I see. It sends that R until the button is released. So R is when the button was pushed down, and then P was sent when it was released. So if I hold the button, I'm going to hold the scan button, holding, and I'm just still holding it, and now I'm going to release it. That is, I guess that's how they're doing long presses for functions that require long presses. So there was got to be some kind of long press. So the command is an R. Yeah, maybe that's okay. I know that you pushed a button, but I'm waiting for a long press or something. Because then when I let the button go, it sends a P. So there's got to be some kind of long press detection, and the long presses must be detected at the other micro instead of the front panel. That's bizarre, but I guess this is one way to do it. So I'm going to try color. So that was sending the colors are looping now. So this was it was a Q and then a P. Okay, so the P is when the button gets let up, I'm guessing. So when you release the key, it sends a P, and it must determine the time between you push the key that you're interested in. So the Q was pushing the color button, and then it measures the time from, it probably starts a timer. Okay, Q, the button was pushed. When was the button released? How long did it take? And then we got a P. So, okay, the button was released. This is, of course, where it's going to say call loop, because that's what it went into. It went into a color. It just looping. It's just changing colors right now. And this is where it just returned the display back to the original writing on it. And it's just cycling the colors. So if we just look and see what it's doing, it's not sending any data. So the color looping is probably just simply done on the front panel by the micro that is on the front panel itself. So that front panel micro is responsible for looping the color. So if I just go ahead and tell it the color blue and just leave it there, that'd be fine. Let's try one more thing, and then I'm just going to call it a night on this one, because it's you know, pretty piece of piss. It's simple. So let's try a mode change. Right now it's in lower sideband. So I'm just going to flip it once over to the left to go upper sideband. So that was an upper sideband command. It's a mode change. So that's 2, an H, and then a C were sent. And then of course this is mode USB. So it's just a matter of map all that stuff out. So we know what commands to send. Clearly we know what it looks like to send a long press command. So if I do func one more time, I'm going to push the func key. Make sure this thing is actually capturing data. I'm going to push the func, run this, and I'm going to push the func key, I'm going to hold it. So there's the func key. Alright, and then it changed, the display actually changed to something. Okay, so there's the, so this is the T, because I didn't release it, so this would be the P. So once it sent the P, I'm going to set fin 0.5K, and this is where it sent the, that's very interesting. I thought that it seemed like it was doing something with a long press on that button. So I'm going to try that again. Func, long press. Right, it said fin 0.5K. I'm going to release a button. It stayed there. It just went back to the original display afterwards. You know, with the SR-955. So this is where it says fin 0.5K. And this, of course, this is where it says SR-955 again. So, yeah, that's the T, which is the button you pushed, and then the P is the when the button was released for long press detection. So, and that is pretty much how you work out what these things do. This is going to be compared to the 980 and the McKinley, this is going to be easy to decipher. So you know, maybe I'll get more interested in this, because I mean it's RS-232, it's a piece of piss. Maybe I'll get interested in mucking around with this protocol, and maybe I'll write a .NET application so that you can jack into the radio and issue commands and do your own thing with it. You know, now maybe tomorrow or some point, maybe not tomorrow, but maybe in the future, tomorrow being, of course, the 29th of a Wednesday, maybe I'll look at that back USB and see what's going on there, if that's really USB or if that's RS-232. So anyway, guys, hope you liked it. You know, stay tuned for more SR-955 hackery. Catch you later.